This video is about the conservation of momentum. All objects in motion have momentum. Momentum is calculated using the equation. Momentum in kilograms meters per second is equal to mass in kilograms times velocity in meters per second. The symbol P is used to represent momentum. These two objects move towards each other and collide. Momentum is conserved. We are taking the right direction as positive and the left direction as negative. The principle of the conservation of momentum states that the total momentum before a collision is equal to the total momentum after a collision. The red object of mass little m is moving towards a stationary object of mass big M. The stationary mass has an initial velocity of 0, so an initial momentum of 0. The red object has an initial velocity of little u, so the momentum before the collision is little m times little u. After the collision, the objects are now moving away from each other. This means the velocity of the red object is negative, as it is moving in the opposite direction to before. The blue object is now moving, so now has momentum. Its velocity is big V and is positive, so the momentum of both objects after impact is given by big M times big V minus little m times little v. In this worked example, calculate the velocity of the van after the collision for 4 marks. First, draw and label a diagram to represent all the information. Let's start with the masses, as this does not change during the collision. We must use different symbols for each mass and velocity so we don't get confused. The car is driving along, which means it is moving forwards at 20 meters per second. Adding arrows to the diagram is essential to understand what is happening in the collision. The van is reversing, traveling backwards towards the car at 5 meters per second. After impact, the car must travel backwards because the van was reversing. The car has a final velocity of 2 meters per second. We have got to find the final velocity of the van, so let's add that into the diagram too. It is very important to add all the information to your diagram carefully. The first step in answering this question is to state the conservation of momentum for 1 mark. Now let's calculate the total momentum before the collision. Momentum is equal to mass times velocity. For the car, this is 850 times 20, which equals 17,000 kilograms meters per second. It is plus 20 because the car is moving forwards in the positive direction. For the van, this is 5,600 times minus 5, which equals minus 28,000 kilograms meters per second. It is minus 5 because the van is traveling in the opposite direction to the car. Now find the difference between the two momenta to obtain the total. The total is equal to 17,000 minus 28,000, which is equal to minus 11,000 kilograms meters per second for 1 mark. Use the same method as before to calculate the momentum after the collision. For the car, this is 850 times minus 2, which is equal to minus 1,700 kilograms meters per second. It is minus 2 because the car is moving backwards to the left. For the van, this is 5,600 times the final velocity of the van. So the momentum after the collision is minus 1,700, add 5,600 times the final velocity of the van for 1 mark. The final step is to use the conservation of momentum to equate the momentum before and the momentum after. So, minus 11,000 is equal to minus 1,700 plus 5,600 times the final velocity of the van. Rearrange and simplify to get minus 9,300 is equal to 5,600 times the velocity of the van. Then divide both sides by 5,600 to get the final velocity of the van, which is equal to minus 1.66 meters per second for the final mark. This means the van continues reversing, but due to the impact with the car, does so at a slower speed. Show each step of the rearrangement so you are less likely to make a mistake. In summary, an object in motion has momentum. The equation for momentum is momentum in kilograms meters per second is equal to mass in kilograms times velocity in meters per second. During a collision, momentum is conserved. The conservation of momentum states the total momentum before a collision is equal to the total momentum after a collision. You must carefully consider the direction of motion before and after a collision.